On May 11, 2024, at around 8 a.m. local time, one of the world's richest billionaires, Elon Musk, posted on Twitter stating that the current geomagnetic storm, caused by solar wind, is the largest one in a long time. He noted that the pressure on Starlink satellites was extremely high, but so far, they were still holding steady. On May 9th, NASA's Solar Dynamics Observatory captured a solar flare, also known as a solar storm, that triggered the most severe geomagnetic event in nearly 20 years. By the evening of May 10th, the National Oceanic and Atmospheric Administration, NOAA, announced that Earth was experiencing a G5 class geomagnetic storm, an extremely strong level. This is the first G5 level storm since 2003. Then, on May 15th, the sun erupted again. NOAA reported that just minutes prior, a massive solar flare of magnitude X8.7 had occurred, marking the strongest flare in the current solar cycle. Tuija Pulkkinen, chair of the Department of Climate and Space Sciences at the University of Michigan, warned that following the peak of the last solar cycle, companies like SpaceX have launched thousands of satellites into low Earth orbit. Many companies have reported that they've never seen this kind of space weather effect before, and the orbits of these satellites could very well be unintentionally altered. If that really happens, we're in serious trouble. We all know that life on Earth depends on the sun's thermal and radiant energy to survive. But if the sun's mood becomes too unstable, solar radiation could spiral out of control. This would be followed by billions of tons of charged solar energy racing toward Earth at thousands of miles per second. What kind of catastrophe would that bring? Wouldn't life on Earth be facing the risk of total annihilation? So then why is it that, despite countless warnings about solar storms, Earth has not yet suffered the kind of catastrophic damage scientists have predicted? What is it? Or who is it that's protecting us? Today, let's talk about who's protecting Earth from solar storms. According to research by the United States Geological Survey, USGS, our sun appears to be a rather hot-tempered and restless star. During moments of extreme activity, it emits large amounts of solar flares, bursts of energy that carry magnetic fields and charged particles. This is what we call a solar storm. During such events, the sun releases massive amounts of plasma and magnetic energy from its corona, the outermost layer of its atmosphere, into the heliosphere. This astronomical phenomenon is known as a coronal mass ejection, CME. Each time a CME occurs, the plasma and magnetic energy released from the sun's outer atmosphere can reach billions of tons. Moreover, the speed of solar flares is incredibly fast, traveling at the speed of light, taking only 8 minutes to reach Earth. Meanwhile, CMEs move more slowly and steadily by comparison. According to current scientific calculations, the speed of solar material can reach up to 800 kilometers per second. Much like Earth's weather, the sun also experiences cycles of calm and intense activity. However, the sun's cycle is longer, typically lasting 11 years, and is known as the solar sunspot activity cycle. The recent coronal mass ejection, CME, originated from a massive sunspot group that is 16 times larger than Earth. Generally, if the solar flare isn't too intense, the incoming solar particles will collide with Earth's atmosphere and trigger magnificent auroras. This time, the impact of the solar storm prompted people around the world to share stunning aurora photos online. Images have been posted from Russia, the Scandinavian Peninsula, the United Kingdom, and various parts of continental Europe. Some even claim that auroras were visible as far south as Mallorca in southern Spain. If you found this video interesting, don't forget to hit like and subscribe so you won't miss the next exciting adventures. In the early morning of May 11th, astrophotographer Jeff Bin began his stargazing journey. He excitedly shared a photo of a massive aurora he captured in Aksu, Xinjiang, reportedly the strongest aurora seen in the area in 20 years. Jeff described how the entire northern sky was glowing red, clearly visible to the naked eye. In addition to the vivid red, he also spotted rare green auroras. The scene was truly dreamlike and poetic, he said with excitement. However, if the solar flare or emission becomes too intense, resulting in a solar storm heading toward Earth, then the reality behind those beautiful auroras becomes far less romantic. Because geological conditions vary between cities, the risk of power outages will differ by region. The stronger the solar flare, the more likely it is to cause a geomagnetic storm. In extreme cases, such a storm could damage Earth's magnetosphere and cause severe disruptions to global power infrastructure. According to forecast data from the Space Weather Prediction Center under the Chinese Academy of Sciences, on May 13th, the Sun experienced continuous eruptions from 8:15 a.m. to 8:50 a.m., marking the longest sustained flare duration in the recent series of solar activities. This event triggered a geomagnetic storm. The United States issued warnings to satellite operators, aviation companies, and power grid managers, urging them to implement preventive measures in preparation for possible disruptions caused by fluctuations in Earth's magnetic field. So the big question is, what exactly is a geomagnetic storm? And how can it affect us? Why do governments warn people like this? Scientists warn that solar storms must never be taken lightly. Typically, when the sun releases a powerful solar flare toward Earth, the electromagnetic energy it carries travels at the speed of light, exciting particles in the upper atmosphere and causing radio signal disruptions. If the flare is particularly strong, the radio communications relied upon by airlines and satellite navigation systems can experience serious malfunctions or even complete blackouts for up to 30 minutes. Following that, a massive wave of electrons and protons arrives at near light speed, which can damage the electronic circuits on satellites and potentially threaten the lives of astronauts operating outside Earth's magnetic shield. Then, within 18 hours to a few days, a gigantic plasma cloud from the coronal mass ejection, CME, crashes into Earth's magnetosphere at speeds reaching 3,100 kilometers per second. This process severely disrupts Earth's magnetic field, leading to global-scale electromagnetic disturbances. If you found this video interesting, don't forget to hit like and subscribe so you won't miss the next exciting adventures. A geomagnetic storm is essentially a type of intense, global electromagnetic disturbance. It is a major disruption in Earth's surrounding space environment, typically caused by high-speed plasma clouds colliding with Earth's magnetosphere. The intensity of a geomagnetic storm usually reflects how strongly these plasma clouds impact Earth and is measured using electromagnetic indices. Generally, the strength is assessed using two main indices, KP index and DST index. Scientists tend to rely on the DST index in academic research, while the KP index is more commonly used in real-time space weather forecasts. For example, the geomagnetic storm triggered by the solar flare on May 9th produced a KP index reading of 8 to 9 on May 10th and 11th. On May 12, it dropped to 6 to 7, and by May 13th, even though the solar flare had the longest recorded duration, the KP index decreased to 6. As a result of geomagnetic storms, space stations may experience orbital drag due to atmospheric expansion, which causes their orbital altitudes to decrease. GPS and satellite navigation systems may show increased positioning errors. Spaceflight operations also face a dual risk: degraded communication and dangerous polar radiation exposure. That's why Elon Musk has expressed deep concern, because the consequences of geomagnetic storms are massive. If such a storm becomes extremely severe, it can cause strong induced currents in long electrical conductors within power grids, resulting in serious damage or even permanent destruction. These events can also trigger large-scale blackouts. For example, in 1989, a powerful geomagnetic storm caused a massive power outage in Quebec, Canada. Then, in 2003, another strong storm knocked out power in Sweden and damaged transformers in South Africa. But perhaps the most dramatic of all was the Carrington event of 1859, considered the most powerful geomagnetic storm ever recorded. In the early morning of September 1st, 1859, a sudden brilliant white light erupted from a group of massive sunspots on the sun's northern hemisphere, forming a pair of blinding crescent-shaped flashes. This marked an extremely intense solar storm, part of solar cycle 10, during which a coronal mass ejection, CME, slammed into Earth's magnetic field, triggering the largest geomagnetic storm ever observed. At that time in England, there was an astronomy enthusiast named Richard Carrington. Carrington was a wealthy man, and to fulfill his passion for astronomy, he built a home near London along with a private observatory. Day after day, he spent his time observing the sun, determined to study sunspots in order to precisely determine the sun's rotational cycle. Fortune favors the dedicated. Carrington eventually made a groundbreaking discovery. Due to differences in solar latitude, the movement speed of sunspots across the sun's surface also varies. At the sun's equator, a sunspot takes only about 25 days to complete a full rotation. But at 45 degrees latitude, the same journey takes around 27.5 days. This discovery shocked the astronomical community at the time, as it proved that the sun was not a solid glowing sphere, as many astronomers then believed, but rather a massive gaseous ball with differential rotation depending on latitude. On the morning of September 1st, 1859, while observing sunspots, Richard Carrington noticed that within a large sunspot group in the sun's northern hemisphere, two massive white light flares suddenly appeared, forming a pair of intensely bright crescent-shaped flashes adjacent to the spots. Carrington immediately reported the phenomenon to the Royal Astronomical Society. At the same time, another English astronomer, Richard Hodgson, also witnessed the same solar flare and submitted his own observations. However, Carrington was credited with the discovery, and thus, the event became known as the Carrington event. When the Carrington event occurred, telegraph systems around the world malfunctioned, and some telegraph operators were even shocked by electric surges. The auroras caused by the geomagnetic storm were seen as far south as Hawaii, and they were so bright that people could read newspapers at night without any artificial light. If such an intense geomagnetic storm were to occur today, in a world highly dependent on electricity, our modern infrastructure could suffer devastating damage, and the scale of losses would be nearly impossible to estimate. However, whether it was the powerful geomagnetic storm during the Carrington event or the recent solar flare, the expected catastrophic damage did not actually occur. On the contrary, many people had the rare chance to witness breathtaking, magnificent auroras with their own eyes. So what exactly is going on here? Is someone or something protecting Earth? The answer lies in Earth's atmosphere, which acts as an invisible shield, protecting our planet from the most intense solar radiation in over 20 years and preventing major losses. Let's first take a quick look at the structure of the atmosphere, and you'll see why it's so crucial. The atmosphere, also known as the aerial shell, is a layer of mixed gases surrounding the Earth, held in place by gravity. It extends up to approximately 1,000 kilometers above the Earth's surface. At the lowest level, from ground level up to around 12 kilometers, lies the troposphere. This is where clouds and rain typically form. The layer located 10 to 50 kilometers above Earth's surface is called the stratosphere. This layer plays a vital role by absorbing ultraviolet, UV radiation, protecting all life forms on Earth, and shielding the planet's surface from deadly UV penetration. The region 50 to 58 kilometers above ground is known as the mesosphere. Here, temperature decreases as altitude increases. At 60 to 68 kilometers, we enter the ionosphere, the boundary between Earth and outer space. This is one of the least understood layers, as the air here is extremely thin, filled with numerous charged ions, and temperatures are quite high, continuing to rise with altitude. The ionosphere has direct effects on human communications, including mobile phone signals, satellite navigation, radio telescopes, and even our understanding of global weather systems. Lastly, from 85 to 1,000 kilometers above the surface lies the exosphere, the gateway to outer space. This is the first region that coronal mass ejections, CMEs, will reach if a solar flare occurs. We all know that it is thanks to the existence of Earth's atmosphere that life was able to emerge and flourish on this planet. The atmosphere not only helps maintain Earth's temperature, ensuring the normal development and growth of life, but also weakens harmful solar radiation. In other words, the atmosphere serves as Earth's most crucial protective shield for both the planet and humanity. Any changes in the atmosphere directly influence climate change and have a significant impact on human life. The temperature of the sun's corona is incredibly high, but the plasma there is extremely thin. These charged particles are typically confined by the sun's magnetic field. However, under certain conditions, for instance, when the sun sneezes, these particles can escape into space. When these charged particles enter Earth's magnetosphere, they can cause it to contract and deform, LOW. High-energy particle streams and geomagnetic disturbances in space can affect both electronic components and the flight dynamics of satellites and space stations. During strong geomagnetic storms, low Earth orbit spacecraft may experience disruptions due to increased atmospheric density, which can result in orbital changes. That's why we should be grateful for the atmosphere, and even more so, grateful to the Creator who designed it. When the strongest solar flare in 20 years struck Earth with an immense solar storm, it was our atmosphere, acting like a divine guardian, that once again shielded humanity from a potentially catastrophic disaster. Think about it. The atmosphere is so precise and wondrous in its design. Could this not be another sign of a higher power watching over us? Interestingly, scientists once believed that the main factors altering the ionosphere were solar radiation, atmospheric turbulence, and electromagnetic activity. As a result, the world has reached a global consensus on the importance of protecting Earth's atmosphere. However, in 2018, British scientists made a truly astonishing scientific discovery. They revealed that World War II had weakened Earth's atmosphere. In other words, human activities, like war, can also impact the ionosphere. It turns out that during World War II, shockwaves from Allied bomb explosions were powerful enough to penetrate Earth's atmosphere and reach outer space. According to data, the blast waves from those bombs were still detectable at altitudes of up to 1,000 kilometers, right above British airspace. This study was published in the Annals of Geophysics, one of the world's leading journals in the field of geophysics. With nothing more than conventional warfare from nearly a century ago, humanity had already caused measurable harm to the atmosphere. We often believe the greatest threats come from outer space, but sometimes the deepest wounds are caused from within, by humanity itself. The atmosphere, our invisible yet invaluable shield, has silently protected us for billions of years, shielding us from cosmic radiation, solar storms, and natural disasters. Yet within just a few short centuries, humans have unknowingly weakened it through war, pollution, and ignorance. We've witnessed wonders, from breathtaking auroras to the miracle of life thriving on Earth. But all of it exists solely because of a fragile, miraculous layer of gas encasing our planet. If a single bomb can shake the ionosphere, then a single action from each of us today can help revive Earth for tomorrow. Be grateful and act for the atmosphere, for the planet, for ourselves. If you found this video interesting, don't forget to hit like and subscribe so you won't miss the next exciting adventures.